Okay, good day everyone. Welcome to Ice Cream Maths Academy, where numbers, variables actually meet mastery. So now I want us to look at another example under the implicit function. Remember we started with the difference between implicit and explicit function, and we said for an implicit function, the relationship between x and y is much more involved, just like what we're seeing here. Here we have 5xy squared plus tan xy is equal to sin x squared y. Now you can see that the relationship between x and y is much more involved. So it means in this case, you cannot just start with the y all over the x like the case of explicit functions. So it means here, we start by saying differentiating term by term. Okay, so now we're going to start with the first one here, the first term here. We have 5xy squared. Now, if you look at this very closely, you will discover that 5xy squared is actually the product of 5x and y squared, or 5y squared and x. So it means here we are going to be applying the product rule. And remember what the product rule actually said, that if y is equal to uv, that the y all over the x is v the u plus u the v all over the x. I mean, if y is equal to uv, the y the x is v the u all over the x plus u the v all over the x. Now it means in this case, yes, now I'm taking this to be my u and this to be v. Yes, so now I'll pick the v, y squared, and I'll differentiate u. Now when you differentiate 5x, it gives you 5 plus, now you pick the u, which is 5x. Now when you differentiate y squared, just like when you differentiate x squared, it gives you 2x. Now when you differentiate y squared, it gives you 2y. But because you are differentiating with respect to x, it means you have it as 2y, then you follow it up with the y all over the x. Yes, then plus. Now this is actually a function of x and y. Now remember we said if y is equal to tan x, that the y all over the x will give us tan sec squared x. Now, but in this case, you will see that here we have xy as the function here. So it means to differentiate this, you have sec squared xy, then you times it by the derivative of this function. Yes, you times it by the derivative of x and y. And of course, x and y is the product of x and y. So it means in this case, we are going to use the product rule to differentiate xy. So I'll pick y, I'll differentiate x, that's 1. And now I'll pick x, I'll differentiate y. When you differentiate y, you have 1. Then you follow it with the y all over the x, because you are actually differentiating with respect to x. Now the whole of this now will be equal to, now the same thing applies to this. Yes, this is actually a functional function involving x squared and y. So you differentiate sine x squared y, that will give you cos x squared y. Then now you multiply it by the derivative of this function. Yes, just like when you have y is equal to sine 8x, and you want to get the y dx. The y dx will just be, when you differentiate this, you have cos 8x, then you times it by the derivative of this function, and that will give you 8. So here you have it as 8 cos 8x. Now, that's what we are applying here. Now, differentiating sine x squared y will give us cos x squared y. Then you times it by the derivative. So now you pick y. You differentiate x squared. That will be 2x plus, you pick x squared, you differentiate y. You know, when you differentiate y, it gives 1. But because we actually doing it with respect to x, you follow it with the y all over the x. Yes, you follow it with the y all over the x. So it means the whole of this now will be, we have 5y squared plus, if you multiply 5x times 2y, we have 10xy, the y all over the x plus, now when you multiply the whole of this by this, you have it as y plus x, the y all over the x, then you have sec squared xy. Yes, now the whole of this now will be equal to, yes, it will be equal to, this times this now will be, you have 2xy plus x squared, the y all over the x, times cos x squared y. Yes, times x squared y. Now we're going to expand this and of course this. Yes, so expanding this, what we have now will be, we have 5y squared plus 10xy, the y all over the x, plus, now y times sec square xy, it will give y sec square xy, plus x, the y all over the x times this, it gives x, the y all over the x, then we have sec square xy. Now the whole of this will be equal to, when you multiply this times this, it gives 2xy cos, we have x square y, plus this, we give x square, we have the y all over the x, then here we have cos x square y. Now we have expanded. Yes, we have expanded. Now let's collect all the y dx. So collecting all the y all over the x. Yes, collecting all the functions. Yes, collecting all the functions with the y dx. So therefore means that here, what we have here now will be, we have 5y squared. This one has no the y dx. This one has no the y dx. So here we have plus y sec square xy. Now the whole of this, now let's look at it. This one has no the y dx. So now I'm bringing it to this other side, to the left hand side. And remember here it is plus. It is actually a plus value here. So bringing it to the other side, it becomes minus 2xy cos, here we have x square y. Now the whole of this will be equal to, here we have x square, the y all over the x, cos, we have x square y. Now I'm taking all the functions with the y dx to the other side. So this is plus 10xy the y dx. So taking it to the side, you have minus 10xy the y all over the x. Now this is another function with the y dx. So taking it to the other side, you have minus x the y all over the x. Then here we have sec squared xy. Okay, now in this case, what we have here now will be, we have 5y squared plus y sec square xy minus 2xy cos x square y will be equal to, now because the y dx is actually common in the whole of this function, I want to factor out the y dx. So here it means we have the y all over the x, then in brackets, here this one is out, so the y dx is out, so here we'll be left with x square cos x square y. Now the y dx is out, so here we have minus 10xy. Here the y dx is out, we have minus x sec square xy. Okay, now to get the value of the y all over the x, the y all over the x, the y all over the x, will be equal to, now the whole of this function. So here we have 5y square plus, here we have y sec squared xy minus, we have 2xy, then we have cos x square y, now divide by the whole of this. Okay, so here we have x square, cos x square y minus 10xy minus x minus x, and here we have sec square xy. Sec square xy. Now it means here we have the y all over the x now will be equal to. Now if you look at the denominator very closely, you will see that y is common. Here we have y square, here we have y, and here we have xy. So it means y is common in the numerator. So here I'll pick y outside, factor it out. Here I'll be left with 5y plus this y is out. So we have sec squared xy. Then here we have minus this y is out. So here we have 2x cos we have x squared y, the whole of this all over. Now looking at the denominator, you will see that x is common. There's x squared here, there's xy here, and there's x here. It means what we'll have will be x in brackets x cos x squared y minus now out of these 10xy, x is outside, so here we'll be left with 10y. Then here we have minus, now this x is out, so we have sec squared xy. So yes, that ends this very question. So it means given this implicit function, the y all over the x will be equal to the whole of this. So thank you for listening and watch out for more examples. Thank you so much.